Hello everyone, this is your tutor AV. Today we're going to be solving a problem from the May 2021 IB Physics SL examinations. This is from paper 1 and it's a multiple choice question. Let's get started. A circuit contains a variable resistor of maximum resistance R and a fixed resistor, also of resistance R, connected in series. The EMF of the battery is 6 volts and its internal resistance is negligible. What are the initial and final voltmeter readings when the variable resistor is increased from an initial resistance of 0 to a final resistance of R? So essentially there are two cases for this circuit, case 1 and case 2. So let's just draw two circuits and find out what's the exact situation. Of course you don't need to draw the circuit, we can find out without the circuit itself, but just for learning I'll draw it. Okay, so you have one circuit like this, right? We only need one resistor for the first case when the second variable resistor's resistance is 0, because when it has a resistance of 0 it doesn't even matter, it's not doing anything, it's not contributing to the circuit, right? So we can say that it has a total resistance in the circuit of R and it has a potential difference 6. Now the main way to distribute a potential difference across branches or of course in the circuit is by finding out particular ratios of resistances. But in this case there is no other resistance, there's only one resistor of resistance R in the circuit. So this resistance R gets the full 6 volts. It gets the full 6 volts of potential drop. There's nothing else to split this potential with, right? Because we split potential with ratios of resistance. When there's only one resistor, we don't need to split it into anything, it gets the full amount. So the initial reading must be 6 volts. So it must be 6 volts. In case 2, we can say that there are two resistors now. Both the resistors are R and R. Now what happens in this case? Well, this 6 volts has to be split into a ratio. This ratio is of course 1:1 because these R's have equal value. So 1:1. When I split 6 volts into 1:1, I find that one resistor gets 3 volts, the other resistor gets 3 volts because it gets split in a ratio, equal ratio. So the initial reading of the voltmeter must be 6 volts and the final reading of the voltmeter must be 3 volts, right? So that's your answer. Thank you for watching. Please like and subscribe. If you have any questions, leave it down below.